today's webinar, Avoiding Pitfalls and Building a Successful Data Mesh. I'm Melissa Brownlee, Marketing Manager for ER Studio, and we're going to get started. So today's discussion focuses on data mesh, its challenges, best practices, and how to implement it effectively. This webinar also references a blog written by our guest speaker, Hans Lux, which is now available on the ER Studio blog. In it, Hans breaks down the key pitfalls and strategies for success. So be sure to check it out after today's session. So now I'm going to turn it over to Jamie and Hans to get started.
Cool. So, Hans, you've been working in data warehousing for a long time. Tell us a bit about your history.
Well, when I was done with my degree, with my doctoral degree from the University of Illinois, that was in statistics and test and measurement, and I wanted to do research-related work, and then I found a position in a small university in northernmost Maine, and there was a need to do a lot of work for internal decision support. And I proposed to create a computing system to support this. And little did I know that I was building the first fully automated data warehouse for a university that I'm aware of. That was in the early 90s. And that really got me started with analytic data systems. And I always found it to be a very interesting theme because you can do so much with so little. It's probably the biggest ROI you can get out of anything. You just get your data in shape, and then everything else flows. And that has actually never changed. And it's still the same problem, data quality and getting the data for analytics, whether that's now AI or whatever, it's still the big topic. And then I got into data modeling, had a practice for about 10 years or so. We worked a lot with ER Studio, as a matter of fact, but also with the other tools, of course. And then got on into enterprise data architecture, which seeks a different problem, solve a different problem where we're no longer concerned about individual systems, but how all those things work together in landscapes. And I found that actually rather entertaining and exciting because it's challenging you to look at things from a completely different angle. And I had an opportunity within UBS to develop a lot of the methods and do a lot of internal white papers and really wrap my mind around how to get data architecture, data governance, all those things together in one consolidated, holistic whole that works. And then towards my last years there, the topic data mesh came up with all its potential, but also with all its potential problems. And so I started to work on that quite intensely while I was still at UBS. And then I had a project here in Switzerland for a large insurance company, which was a pure data mesh project, and that really rubbed my nose right into it in the middle of it. And I saw the really great potential, but also what it takes to do it right, and that's not particularly trivial.
Very good. So we're hearing so much about data mesh and the notion of data as a product at the moment. So at a high level, what is it?
Well, on a high level, it's actually very straightforward, and the literature hides this a bit. Fundamentally, what it says, treat analytic data like you would treat a product with an owner or a person responsible for it, with SLAs, with understood quality criteria, but also in a way that it's actually usable. Because what data very often are, they're byproduct of other things, of the operational systems, and as a byproduct, I get the analytic data. That's very nice. Thank you very much. But it's not necessarily easy to use. It's not necessarily documented. Very often it isn't at all. And so as analysts start to work to do an inordinate amount of forensic data work, rather than just doing analysis. Now, what the data mesh tries to do, it tries to say, have the quality criteria, make data understandable, make it easy to combine, make it easy to use, make it easy to find. But then there's another topic that if you have centralized data teams or any kind of centralization, you create bottlenecks. And if you try to do more things, then that's going to really break the whole approach. But so there, and that picks up on a book by Eric Evans on domain-driven design. So that pushes the work to the domains, and for two reasons. A, it alleviates the bottleneck, but also it puts the people in charge of analytic data who know this data best. At least that's the theory. For that to work, you now have people doing data who aren't really data people. You need to support them, and that's where the self-service platform comes in. And then, of course, now as you decentralize, you create yourself a governance headache. So some of that is being alleviated with automated a governance or governance system. So where a lot of stuff is just calculated and scores given and things of that nature. And those are really the four principles. I kind of changed the order because I think the quality is the most important one. But nevertheless, I mean, nobody would argue with those. Nobody would argue with those ideas.
So in summary, then, it's an approach to data analytics that focuses on quality and efficiency with data governance built in.
In a way, yeah, you could say that.
Right, that makes sense. So what's new about this? What have we been doing before all this? Why is it special to what we did before?
I think the biggest two changes is to get to the domain. So that's the principle one, and maybe I start with that. So in essence, you say you don't have a data warehousing team, but you've distributed teams. That's not entirely new, though, and this is one of the things. I mean, Deganis talks about an inflection point and a crisis in data, and I mean, in my opinion, there's no crisis. I mean, it has always been bad because companies spend as much on data as they see a value, and so therefore, analytic data will always be problematic because apparently the companies don't see the value to really clean them up. I think you could have a huge ROI on doing that, but that argument is hard to make. So one of it is even with a large warehousing team, those are domain organized anyways. So yes, you have an umbrella, but then you have two people doing domain X and you have other two people doing domain Y. So it's really not changing that much. But if you see this as a matrix organization, if you flip it around and say you're now responsible for the domain first and the data warehousing team second, then it does change. That does change the dynamics, and that's probably a good idea. And again, to focus on people who know their data, being responsible for analytic data, I think that's a very good idea because analytic data tends to be orphaned, and so you get them out of the orphanage into the proper parents. And yeah, that's always good. I mean, kids react well to that, and data react well to that. So there we go. The second thing is this whole thing about quality. One of the things that Degani does really well in the book, she describes criteria of data quality. Now you can quibble with that. You can say some of them are not important, some of them are, but 5 of them she's spot on. They're really important, and she describes it fairly well. And basically she says data need to be understandable, and we're running afoul of that, and we have been running afoul of that since data exists. It's coded in a funny way. It's not quite understood how it is. It's not complete. All those things, and if just that is being done, it's a huge advantage. So those are the two key pieces. So much said, if you aren't in need of a data mesh, it's still quite worthwhile to consider how you can use those ideas for quality in any kind of analytic data environment. There's no reason why you couldn't do that. And at the same time, even if you stay with a data warehouse or data lake or lake house or whatever you do, why not consider reorganizing in a domain-driven way, even if the same people working together with the same people, but the moment those people report to the domain, they are forced to look at it through the eyes of the domain, and that will make a huge difference. So those are very easy things to do without ever doing a data mesh.
So just to summarize those, so there's 4 principles there. The first one, treating data as a product, which is all about quality. And I think this is a really sort of interesting difference. With data's been a kind of second-class citizen. It's just been something that just
you make analytic data first-class citizen, and I think that's a very good idea.
Nice. And so data as a product, those products are well defined with governance principles established for them early on.
Yes.
Cool. Then splitting the organization into domains. So we're saying that we're getting the subject matter experts owning those domains, and that provides another focus on quality.
Well, yes. However, I think she overstates her case here, because that's the reality anyways. You go to any large organization, they have been doing capability models years ago, and they were plus minus organized by capability. Now it was cleaned up and so on, and it's all very good, but by and large that has been there. And IT organizations also have been dedicated to those domains for a long time. So that isn't entirely new. What is new that you say on analytic data, put the primary responsibility to domain and the secondary responsibility to IT. That's really the only realistic change that it does, because you look at the projects and you will find the same people that were sitting in data warehousing 2 years later sit in a data mesh and they report to somebody else. That's effectively it. Makes sense.
Cool. So we're decentralizing the approach. We're going away from just a single data warehouse run by IT and a bunch of engineers, and putting all the control in those domain teams, those experts.
Yes, though technically you may very well end up with the very same data warehouse, and they think this is not understood. So this thing is, oh, we have now independent data products, and then you look and then you say, well, okay, fine, it ends up in Databricks. You access it through SQL, and it just looks like the other thing with a few more partitions. So practically, there may not be that much of an interest, that much of a difference. And I think it's well worth, and this is really what I'm trying to say here, and also what they do with the white paper, it's well worth trying to understand what they really say, and then simply say, take what applies to you, take that, forget about the rest, don't tell anybody, even do a data mesh because some people are put off by it, but just see what of those ideas are really worthwhile and use them. So it's a very pragmatic and eclectic approach, because, as I said, with this making this a big fat thing, it becomes expensive, it gets in the wrong direction. When fundamentally the very, very good idea is applicable for everything.
Yeah, I think we'll come back to this sort of notion of does data mesh take us away from a single data warehouse? I think there's we'll come on to that in the later part of this session. And then the last part of the manifesto is this sort of notion of a self-service data platform, making the data more accessible to all, making it easier to manage. So again, managed by the domain teams.
Well, again, this isn't a way funny, because it's nothing new. I mean, I've been doing this for 40 years. I mean, anybody who has a brain in this business, I mean, I can't say it any other way, says, I take certain things, I consolidate it into some sort of a system, of a platform, of a utility, and I give people a way to use that and deploy that with some configuration file or what have you. So, I mean, that has been done with punch cards as far as I can tell, okay? It's more formalized. So, you take this whole platform and you say, these are all the pieces that fit together, and you look very closely that you really have everything covered. So that's actually what the new thing is, that you don't have individual disjoint pieces, but you say, really, there needs to be a consistent platform for doing this. And so then the people who do the work, they get aided that they can actually do their work better. That's number one. But also boilerplate modules are simply there, so they can simply link those in or use those. And then the users get more support to find the stuff and use the stuff.
Yep.
So really the new part is not a dramatic shift, but putting an emphasis to have this in a joined up way.
Yeah, that makes sense. Okay. So this approach has been around a little while. You can go and get Zhamak Debghani's book, the Data Mesh Manifesto, and read it and get started on this. Talk us through sort of what pitfalls you might face and how we might avoid them.
Well, it's funny that you say you might get the book and read it. Yes, you can read it. And you will be stuck immediately, because the book is written in a very excited form, let's say. exercised, what the Americans say, because she's clearly excited about the topic and she's trying to make the case, and that's good. Great, she put the topic on the table. Thanks for that. But it doesn't help understanding. And it literally goes that there's an introduction that says what's going to come. Then there's a chapter which says, this is what I said in the last chapter, now this is what I'm going to say. Then she says it, then she summarizes what it's going to be. In the next chapter, she says what she said. And then there are in-depth chapters at the end of the book. So if you want to find out what data as a product is, you really need to piece it together from 6 or 7 sources. And so what I did, and what somebody who wants to study it would have to do, is I literally took the files and I rearranged them and cut them out and said, okay, oh, this is what it is. And then I realized that some of them I got dramatically wrong. And then sometimes I said, well, she says this makes no sense. And I realized she doesn't say this. And totally unfair to her. But in the confusion, it just goes under. And so one of the things it really takes to restructure it and look at it. But then there's another problem. The language is very confusing. So for example, I have the term data product. And to some extent, it is what everybody would think it is. It's a data set with quality. And then it says, no, actually, that's the machinery that provides such data set. So if I compare this to a car, I don't know, do I buy a car now? Do I buy the factory in Sindelfingen that builds the car? And that kind of language really doesn't help her case. Or some she inherits from Evans, this word ubiquitous language. Well, if you take the Pope's blessing, he says urbi and orbi. So urbi means the world. So ubiquitous would mean a language which is common to everything, but it actually means the language within a domain. So the very opposite. And so there's terminology that simply needs to be retired if it's supposed to be understandable, and then more accessible language used. Again, it's not the end of the world, but it gets into understanding. The fundamental ideas are very good. They just don't help themselves with the language. And so that's really what it takes. Or data contract. I mean, the data contract isn't a contract; it's an offering. And you go into all those things and you say, couldn't you just use accurate language, especially when she says language is dear to her heart? So, I mean, it is what it is.
So it's not something that can be sort of taken verbatim and just executed. It needs some interpretation. It needs a sort of a pragmatic view laid across the top. I mean, do you think it would differ company by company? Would each company have a slightly different approach, or is there a sort of a ubiquitous approach that could be taken?
Well, see, I think where we're getting to, and that's also which then the other issue would be concepts and so on. But let me anticipate that. Fundamentally, the ideas of the data mesh are the ideas of the data mesh. And as far as I'm concerned, and this will be another pitfall, a potential one, it really needs to be done together with best practices and not in lieu of best practices. So again, there is no inflection point, there's no crisis, it's just more of the same. That's where I simply disagree with her opinion. I mean, if you think there is an inflection point, if you think there is a crisis, well, you come to a different conclusion. I mean, that's your prerogative. But if I go into a company and say, watch what you're getting yourself into and don't treat this as something fundamentally different. So those notions and best practices are those notions and best practices for everyone. But the key bit is, you should never just go out and build a data mesh because you think somebody tells you should have a data mesh. You should think what analytic data needs you have in your organization. And based on those needs, you will have a slightly different environment. Because if you have very, very well structured data already, well, then you don't have to do half of those things because you have it already. But you still might want to go to do distributed architecture. And if you don't have much of a data load, but you have a real royal mess in your data, then you might say, well, using data mesh notions, data as a quality domain-driven design to clean this up, but then just end up in a data warehouse is a perfectly valid approach. So in implementation, you will see a lot of differences, but I would argue there are best practices of data governance, there are best practices of modeling, there are best practices of making a domain-driven organization, there are best practices of having a quality data product. Those are always the same, and those should be aimed for. But then I might really say, this is a data set that I use once in a blue moon, who cares? Let the analysts suffer. It's cheaper. And then this is the core data set that everybody uses all day long. Well, it's really worthwhile to put your money on it. So those are simply cost-benefit decisions that need to be made with proper data and proper insight, and then you get the best mix for your money. I think it would be a mistake to say all data have to be quality. No, they don't. Not at all. If I only do a very wild crapshoot to get some sense where the journey ought to be going, and then I use that information to find myself a better analysis with better data, that's perfectly fine. What isn't fine is to say, oh, we have big data now into all sorts of things and make decisions, and the data are bad, the analysis is bad, the interpretation are bad, and every data mistake in the books that every child learns in Statistics 101 in the first 2 weeks is abused, and then you think you have a great thing. That's where the problem is.
So it sounds like sort of before you get started, you've really got to take a pragmatic approach. You've got to involve the experts in your organization, look at the best practices that works for your organization, and build a strategy that is appropriate.
Yeah. And then also a very typical example is, I mean, data warehouses are very expensive. They're always late. But then you go in and you find out, actually, this might be quite good. And with the resources you have, you can't do better. And maybe you should be nice to data warehousing people and just improve it.
Makes sense.
I mean, there's a lot of paradigm shift where you have people hold the old stuff over without telling them something new comes, and then all of a sudden everything crumbles. And by really having an open, involved communication, you would get much better results for the company.
Cool. You've mentioned to me a few times the sort of the need for modeling. Talk me through that.
Okay, well, so here's an interesting one. So Zigani seems to have a hate relationship with modeling. At least this impression I get. Maybe I'm unfair here, but this impression I get. But really, where this whole thing comes from, if I go into domain-driven work, then I need to have the models by the domain. So instead of having an enterprise model, I have domain models. Now, if I do that, I have a coordination issue. And this is probably where this whole data mesh topic is by far the most dangerous and most difficult. Because what will happen when you get the typical data model in with 20, 30 years experience, as most are, because most people are really at the end of their careers in this business, they say, well, you need to have an enterprise model, you need to have a canonical model. Then the people who read the book are also people who come from the agile bit and people who come from development. There's no way, absolutely no way. So you're shut out before you're in, even though that might be the way to go. So what you end up having to do is you end up to flip this around and say you have domain models that then need to line up. But to make them line up is extra work. Now, Evans, in domain-driven design, he has a few ways to do that. So one is where you say you just keep them consolidated, which dies as soon as you have more than 2 domains. Or you do some translation approach. That's what Degani proposes. Or you have a common core. This is another one of the Evans approaches, where you then say, well, I have the domain models, but they still have to have a common core, which is basically the primary keys, the foreign keys, and maybe the 3 most important data elements per data class. The other thing is, and this is nowhere in the book to be found, but that's my professional opinion, you cannot make any kind of model that goes into an enterprise use that's not reasonably abstracted, because otherwise you will lose the forest for the trees. And that has never worked. And again, this is one of the hot topics with heated discussions where some people say, no, this needs to be modeled out to the last comma. And other people say, I never get done with that, forget it. And so I've always used a highly abstract approach. It has served me really well. I've created systems with dramatic success and longevity with it. So I would use this anytime. I would never do a detailed model. If you combine it with a domain approach around the core model, then you get something that will work, that is scalable, that puts the modeling to the teams that need to do the modeling, but you still assure that you have domain models that line up, that you can combine, where the key relationships can work, and you can make sure when the data products are being built that the primary keys work and that the foreign keys work. And if you can guarantee that, the analysts don't have to test that, which means they will be in steroids, absolutely in steroids. If you don't do that, they spend 80% of the time just testing that the data is still clean.
I'm just wondering if we need to sort of define some of the language that we're using here. So I've heard of customers creating models, but at a very physical level. I think we've got to define, there's modeling and there's modeling. To me, modeling is a tool that is used during that design process. The design process starts from high-level woolly requirements. We then create some sort of model of the information that is agnostic, independent of the technology. And I think that's what you're sort of talking about, that sort of logical model. And then a good tool like ER Studio will then obviously convert that to a physical model that's specific for a particular implementation and then go on to code. So that's sort of design process. And I think what you're talking about is then adding into that design process the notion of architecture, having some sort of reusable, standardized concepts. So yes, as we're creating a model for specific products, we'll be defining what are the things in there, how do we identify these things, the definitions of the things, etc. But I think we're also talking about that reusability, those sort of reusable common architectural patterns. Is that right?
To a point, yes. I mean, what really happens is if you take traditional modeling, the way it's being taught, it says start with a conceptual model, then do a logical model, and then out of that you do the physical models. And I can tell you right away, if you take people who come from a programming at best, hacking at worst background or no background, you lose them right then and there. Will never work. You can have only one model and everything needs to be driven from that model. Now I argue that the conceptual model is already problematic because if I do a conceptual model without data elements, I don't have enough information to even define my structure. So to me, I need data elements to flesh out the classes, and I need classes to define the data elements. So I treat data elements also as first class metadata citizens, if you will. And so I work it from a data element side and work it from the model side. Well, in order to get the precision, I really end up in a logical model anyways. Because among the things what the tools do, and this is one of the things that ER Studio does actually quite well, where it can push from one conceptual model to a lot of different things. I don't really need to do much else. And if I then want to have a conceptual model just for the purpose, for readability, whatever, then I reverse engineer the conceptual model out of the logical model, I'm done. But now I force those poor new modelers who never really wanted to do modeling, not into a whole sequence of models. I just say, focus on a really clean logical model and that's it. And then the rest then can be worked for him. And then you can actually take ER Studio and make it part of the self-service platform and say, well, for the modeling of this whole thing and for the defining of the data product, for making sure that the semantics are clean, you have the tool, maybe some add-ons to it. You might want to combine it with some data element system if need be, or with some governance system if need be. But that actually gives you a basis. And from that basis, you now can push the physical pieces. But you could also, if you really wanted to, now recreate a canonical model. But It's not an intentionally created model, and that's the very important difference. It is a byproduct. It's a very nice byproduct. So you flip the modeling approach around, you make it much, much simpler, and then you still have a lot of standard pieces. So you build in a domain, you build in the data types, you say identifiers can only be defined in a certain way. That's it. And then you can force this with a common kernel anyway, so a lot of that will go. But you could also say names can only be defined in a certain way. So you still push it into the domain, but you give them a bit of the straitjacket that they can't do too much damage.
So I think we're agreeing then. So that design process, we're using a logical model in that design process. We've got some notion of standardization, some sort of common model preferably across the domain, and then maybe between the domains, some sort of kernel of common components that can be shared and reused.
There is not a common model across the domains intentionally done. It only emerges. The only common model is the very, very terse kernel, which is necessary to assure that the domain pieces fit together.
I think that's a big difference between the sort of traditional approach to enterprise data architecture, where you have this sort of big enterprise logical enterprise conceptual model, and then everything hangs off that. So you're talking more of a sort of a bottom-up approach and a sort of collaboration or federation of the domains.
Yeah. That's really the difference.
Nice.
But that one is worthwhile doing. And quite frankly, even if I didn't do a data mesh, if I did just distinct normal canonical model because it's asked for something, I would actually take this process because it will give you better results and it will force ownership of the model, the domains, which means the likelihood that it will be maintained is much higher. Because otherwise it's a propeller head with 30 years modeling experience. And, oh yeah, you're very good at that, but we can't do this.
So in summary, you mentioned the sort of the have at it approach to some analytics. So if I wanted to sort of run a data mesh program where I'm really just going straight to physical models for every data product, I'm designing them in isolation without all that sort of logical modeling stuff, without the sort of common models across the domains, what problems are going to face?
Well, I mean, you will get things that are not joined up. So things will work within the microcosm just fine. And by the way, I mean, if you buy market data, it's perfectly fine to do it that way. Because the shares, the ticker symbol is known with that you can join, you don't need much. I mean, it can be done, absolutely. There's no reason not to do it. If you buy, I mean, weather data, perfect example. I can get grip files from 8 or 9 different vendors. They're about worldwide 10 different models. And if I don't like the US model, I take the French one, which, for example, for Switzerland works much better. And then the vendor says, well, my model is better. So you pay more, then I can decide. Works for me. So I pay more. I say, well, sorry, too expensive. I go back to the freebie. So I have a notion of a data product there inherently. If I have data that I bring in from structured data that already come from an internal system, I don't have such a market, and I shouldn't have the redundancy. If I have the redundancy, something has gone terribly wrong. Governance has failed. And so then it depends. But now when I have this internal data, they always need to line up. I never look at them in isolation. And so for that reason, that common kernel becomes very important. But then effectively the data product becomes a feed into a data warehouse. Now the data mesh people will not be happy about that message, but that's really what they're creating.
Cool. So modeling, I think you're saying is absolutely vital to a successful data mesh program, and modeling where you're building an understanding of the information of a domain and having some notion of standardization across those domains is vital to quality and interoperability. What's next?
Well, there are a couple of things that might be worthwhile considering. So one is there's some concepts within the data mesh that are not really possible to implement as described. And so I think there needs to be some clarity on how to adapt that and make it work. And then the other thing is being presented as some big fat new thing, inflection point and crisis and what have you, paradigm shift. There is a fairly big risk not to focus this whole thing right and say, okay, fine, we build this data mesh. Now we throw everything out blanketly, maybe build a technical implementation first, and then create something that can't be undone. And then there's a last point, and we touched on that. That is the data mesh ideally is complementary to best practices and not in lieu of best practices. And it might be worthwhile to have a look into that also. Those are the three things we really haven't looked into, but those would be the ones that I would suggest we could spend some time on if we have any.
The technical implementation, a technical driven project is something that worries me. We see customers saying, right, we've bought our cloud-based database products, brilliant. We've got a good ETL technology that we're going to use, right, let's build a data mesh on it. And it's driven by the technology. Whereas to me, it feels like this is really a business driven project. And it's going to be focused by the business needs and the domain business teams, not the technologists.
Yeah, I think this is probably where most data mesh projects fail to produce value. So they may be technically successful and people say, oh, I've done a data mesh, it's all very good. But if you really look, you say, what do you spend the money for? And I think on that I can also touch a bit more on the quality issue. So in essence, you say, here's a data mesh. We build this, we do this new paradigm, we do this new thing. Then you might combine it right away with a shift from on-prem to cloud. And so now the IT people come in, well, justifiably, because it's a big challenge. So you say, okay, fine, so let's build a test environment and let's try what we can do. And next thing you know is that this test environment drives everything. And then if your data products are being built, which then somebody uses already in some essential way, and all of a sudden you've created a new system without any kind of design to speak of, that's now in your portfolio, can't be taken out anymore. And what have you done? You've just created the next legacy system. Hooray, wonderful. And I think that is a very, very bad way to go, because you will spend loads of money and you will have very, very bad surprises. And now the other thing is, if you do that, you might create something which then can only be fixed with a high outlay for, let's say, some other software, which then might cost 4, 5, 6 times as much as you have already spent. And then you have decisions for millions that are made within a few weeks, when decisions for thousands weren't made within a few months, and that's really penny wise and pound foolish. And then last but not least, data mesh really primarily is about quality. And if you make this as a technical implementation, then you're very likely not to worry about quality. And so let's just go into this. What does quality mean? Well, quality means I want to find data in the first place. I want to understand what data means in terms of semantics and in terms of syntax. If I don't understand what it means, it's useless. I can't do anything. I need to be able to trust the data quality. I need to be able to trust the data complete and accurate. And I need to be able to combine data with other data. Those are taken from Degani. Okay, I mean, I used my own words, but that's her criteria, and I think she did a very, very good job describing that. Okay, I mean, I've been known to be quite critical of her work, but I really want to praise her where she did a wonderful job, and it's one of those places. That's there's a reason why this was successful. And And so now if you do technical implementation, say, oh, I worry about this later. So now what you've done, you have the same crap data in a new technology. Well, what good does that do you? And if you then go into say, yeah, but she says, I really need to understand the data. If I want to understand the data, I have to have a semantic model. This is what I again get out of this combined domain model. They say, well, we don't have time with this. We have a deadline to get this technical piece out. Then I say, you're building something which you call data mesh, but it falls far short of what it's supposed to be. I mean, she literally says she wants to produce data that the analyst is delighted about. Well, then I say, delight is not necessarily the word I would use, but it tells you about her vision. And I think in that regard, it's actually good to think about that. And then when I look at the data products that I see, delighted is not what would come to mind. And so on that one, I would say that's a big problem. Now, what I would do, I would turn this completely around and I would say, what would I want to do in business terms? So which means if this is freestanding data products, which data products would I want to have? If this is parts of some consolidated data warehouse type of thing or lakehouse type of thing, what kind of data sets would I want to have in there? I would outline what I need for the first 2 years. I would define what it is in terms of quality. And then I would build it on the same old environment I have already paid for. And then I will have one of two experiences. I will either see that I really can't use the environment, but then I will know much, much better what I need, how much I need, and then I can go back with numbers, with volume and consumption numbers that are actually meaningful. Or I might find out that if I do my data products right, I don't have a bottleneck. I can use the old chunk for another 5 years, thank you very much, and not spend any money. What's wrong with that? I flip one I skip one upgrade cycle. In both cases, I will actually serve my business rather than having an interesting technical implementation, which is great for the CV of the people who do it, but there's very little for the company.
Makes sense. Hans, we've run out of time a little bit.
We always do, Jamie. We always do.
This is a great discussion, yeah. So let's wrap up and summarize. So I think what we're saying is that data mesh, a data products driven approach, has some amazing benefits. We can deliver an analytics program that gives us quality, is scalable, longevity, has governance thought about and baked in, with data products that are interoperability, and again, quality, and it's efficient. But in order to get there, there are some things we need to do. We need to build a good plan at the start. We need to do a lot of thinking up front, setting clear objectives, getting our internal and external experts together and build an approach that is pragmatic and works for your organization. We've said that modeling, it's more important than ever. We've got to do the modeling. Otherwise, we're going to have data products that are not interoperable, they're not scalable, they're not fit for purpose, they don't deliver value, they're not going to be governable. And the other part is this whole program has got to be business driven, not technology driven. Anything you want to add to that as a summary, and then we'll go on to questions?
Just minor points. With the modeling, it also will put the domain teams on steroids if it's done right. Because otherwise they will fool around with file-based modeling, and then you have 50 pages of definitions, which is, which gets us back to the 70s. Makes no sense.
We have some great questions coming through, so let me read some of them out. There's a really good one on sort of hearts and minds. So doesn't this approach require a cultural change in the organization, the business taking responsibility for its data rather than pushing it to IT? I think that's really, really important topic there. What do you say to that, Hans?
I think that's one of the key points, because fundamentally, and I think this is one of the problems she really addresses, that a lot of analytical data work was done centrally by IT. And she even says it's literally, she says, well, there are special technologies involved, and so then the people come in, so then the technologists really run the show, and so now the data warehouse becomes really a technical thing, and sometimes the business users are kind of left out. And so now in this case, it's really with the domain, it goes to the business units, but there's still the risk that it becomes a technical implementation within a domain. So I mean, it's still the same issue. If this is really supposed to work, then the business has to be firmly behind it, but also the business has to be responsible for making sure that the data definitions and the data are right. And quite often, even with the data mesh, the business is quite happy to have other people do the work, and then they complain how terrible it is.
Yeah, I'd agree. I think the key to successful data mesh is splitting the domain teams and finding the right subject matter experts. And those subject matter experts are probably going to have two roles. One is defining the products of that domain. The other one is the sort of the governance side of things, working out what is the information that this domain is concerned with, and building out the governance framework. And there's some questions here about how do you decide on the domains? So a domain is a business process, a business function, or what is the definition that we're using?
Well, there is the ideal world, and then there's a reality. And the two don't jibe quite well. The ideal world is you go and you actually define domains by capabilities, and capability modeling is a standardized approach that really forces the capabilities of a company into a hierarchical model, but that's quite good because it takes the repetition out. And then based on that, you figure then out who's responsible for that, and out of sets of capabilities, you get your domains. Some companies do this quite well, and then if you have this, you can jump on and then you're good. In reality, when you look what the domains are, you scratch your head and you say, I have one domain which is so humongous, it's half the company, and then I have a few itty-bitty little domains. Typical example in insurance is the actuarial unit, because everything depends on that. I mean, that's the key success factor. If they get the actuary wrong, then the insurance goes under, and so they are kind of a law on their own, and then they are clearly a domain. But it's actually a fairly small domain, but then their data needs are all over the place. So then really, by and large, most companies pretty much take the business units they have, for better or worse, and that's the domain. The reality is within those domains, so-called domains, quote unquote, it is then possible to say, well, let's just break that down to subdomains, and then really the data products are done on the subdomain and not on the domain.
Yep, I'd agree with that. And I think this is where sort of enterprise architecture and enterprise data architecture then really sort of kick in. And we've been doing this a long time. So a traditional enterprise data model, you'd be splitting the organization into subject areas. So yeah, it's
the same thing.
Exactly.
It's the same thing.
Okay. Who ensures integration CRUD is managed and well orchestrated across these domains?
Well, these are analytical data, so there is no CRUD, because it's already secondary data, and this is also I'm anticipating whether it shouldn't be called analytical data product, and the categorical answer is no. Data products by definition are for analytical data. So really, if you want to qualify, you have to call the ones that are in operational data products, and it might be well worth to qualify those. But fundamentally, when people talk about data products, it's analytic data. And analytic data always secondary, whereas the cooking of data, the CRUD, is really in the primary systems, in the operating systems, and that's where that is an issue. So all this being done with this is being read by and large. Although when a new data product is built, then they create new ones, but that's in another data product. The only people who write and edit this is a domain team that provides the data.
Yep. So there's a question here. You made a statement earlier on, identifiers in a certain way. So if we've got a list of categories, number, string, date, indicator, identifier, from my identifiers, my categories as suffixes of the identifiers. Is this what you're talking about when you make sure to define your identifiers in a certain way?
What I meant to say, not that this is not correct, but what I meant to say is that if you want to assure interoperability, the domain models need to line up. And that is primarily on the primary foreign key pairs, which means every domain must define their identifiers really well and must ensure that the identifier values are valid and fulfill all those conditions, complete and non-redundant and what have you. And where a data product references another data product. So for example, if I have a trade data product, and then I have a financial instrument data product, well, then the trade data product needs to reference the instruments in some reliable way. Then that relationship has to be assured. Well, then people say, well, you can just do this by ticker and so on, and it's fine. I mean, you can to a certain extent, but fundamentally, if you really go in high quality internal data, then that's you may go to an internal key or something like that. And then with that, you need to make sure that all works. So that's what's meant. So much said, on a straitjacket, we define, identify domains, and then say, well, there's a long identifier, there's a short identifier, something like that, and then we identify the references as a domain. So we have, and this is now a modeling domain and not a business domain. So careful, this is a homonym. And so then we define a reference to a long identifier and a reference to a short identifier.
Very good. Next question. Now, you and I have had lots of discussions on this. So enterprise data model versus domain data models. So the question here is that I assume that the domain data models are more recognizable and better understood by the business than an enterprise data model. Wow, we can talk for an hour just on this topic. So I mean, a well-defined enterprise data model split into good subject areas should be understood by the business, and the business should have had adequate contribution to it and approval of it. For a data mesh, though, how is the data model created? And again, Hans was talking earlier about that sort of bottom-up approach. So yeah, you could start with if you've already got a good enterprise data model split into subject areas, great, that could potentially kickstart your data mesh program. But creating one, do you start top down or bottom up? Hans, what do you think?
I mean, if you read what I call the manifesto, which is a data mesh book that Tigani wrote, she's inimical to modeling. And so basically the data product might be done without model, and the model is implicit or it kind of emerges out of that, or you can pull it out. So the domain decides whether or not the domain models, and the domain decides what quality the model, and it's the end of it. Well, you can imagine where this goes. It's going to be a total pandemonium, but fine. So now if you actually implement that, I think it'd be well advised to say, no, there needs to be some modeling, but you push the modeling in the domain, as you said. And that's as understandable or not understandable as any other model, because I mean, in the end, the domain models plus the core roll up to the enterprise data model. So if the same thing, and if it's done well, you can understand. If it's done poorly, well, you understand it's done poorly, and that's pretty much all you understand.
Yep. I think the main thing is just ensuring that consistency across products, consistency across domains, having data models that allow you to standardize on these definitions and share those definitions across domains is what you've got to think about. How it's actually sort of realized in models. There's lots of different options, and come and talk to us with ER Studio, that we've got various approaches to it. So it's a question of choosing an approach that's right for you. Some will have more sort of management overheads than others.
Well, I mean, the other thing is, for example, the granularity tends to be different from domain to domain. So you have some domains that are quite abstract. So if you take stuff like actor type or something like that, and others model it out to the umpteenth degree, and then of course they fall over with multiple inheritance and stuff like that, and then it doesn't quite work. And something like that, you really need to have a common company-wide standard. You need to say, no, actually you go fairly abstract, and this detail comes then in type values and stuff like that. Because otherwise it just will not join up.
Very good. The next question, again, we can talk about this for an hour. The question is, what modeling structure is prescribed for the lakehouse, third normal form or data vault? And I think there's a whole discussion on, so the manifesto kind of eschews the notion of a single central data warehouse. And again, Hans, you and I, we've talked about this a lot. A sort of, does each domain have their own independent warehouse or lakehouse, or is there some sort of centralized approach? Whether it's third normal form or data vault, I don't think really matters. We're seeing a lot of customers talking about building medallion architecture that's going to support their data mesh. The silver layer could be third normal form or data vault. Don't think it really matters. Hans, what do you think? Any comments on that?
I mean, it depends what you want to do with the data. And if you're in a fairly source aligned form, it might not be normalized. But at some point, I think that is very important. Is another thing that she kind of not really fleshes out at all. You need to have some integrated or harmonized tier, and that one needs to be normalized to a very high degree. And I would actually go to fifth normal form, because you really have to break your brain not to end up with fifth normal form anyways, with the exception that the temporization that the data vault might do, although they do it in a quite complex form, that violates fourth normal form, but that's fine because analytic data, you don't break anything with it anyways. So I would say at some point in between, you ought to have a highly normalized version, or whether you go the full Monte with vault or a very short version of the vault, but something like that you will end up having. And then for the consumer alignments, you're back to dimensional models, you're back to stars, because that's what, even if you wouldn't want to do that, that's what the tools expect, and so that's what you deliver.
Very good. We're just about out of time. I've got one sort of parting statement. There's a question that's been put in that I like. We seem to be losing the key reason why data models are done. It is to document the business data to business capabilities enabled by business processes. Without this centering of communication, it will definitely be chaotic.
It is chaotic. People don't want to model anymore. That's a reality. So to draw nice pictures how the company works is usually done by some people in a little filing cabinet who gets a Coke every 2 hours, because nobody cares. It's not being done anymore. The only thing you can do is to modeling that is specific to something you build. And that's the reason why I say go to the logical model. If you're keen on the conceptual model, that will either emerge, which means you pull it out afterwards, or just use very clean conceptual model while you do that, and then you're still fine. It's not the satisfactory answer, but the fact is, modeling isn't liked. So you can only do as much as you can sell, and that's it.
That's right. I think it's a new approach to data modeling that we've got to all think about. Just enough data modeling to deliver the right amount of value.
Well, there would be more, but you have a whole generation of new people who just doesn't want to do it, and they have no problem spending 10 times as much for a project as they could do with a good model. The message does not arrive. I mean, that's either they have to fall on their faces really badly and then get it, or we need to adapt our approach where we say, well, okay, fine, want to build data products is a really good way to do it. Why in the world do you want to type in this stuff the way I did 40 years ago with punch cards? There's a tool that can create you all that code. And I think that's where you actually get it. And the fact it needs to be understandable. I mean, the most important thing of the data mesh was thrown out, which is quality. Nobody cares about quality. And this is really what she's very keen on. So we now build data meshes without building the core what the data mesh is about. And that's again why the argument for the model goes
further away, very much to the detriment to the results.
Very good. So I think we all agree there. Modeling is absolutely vital for a quality data mesh program. Good. We've run out of time. Thanks everybody for joining.